Welcome viewers. In this video we'll see the making single phase induction motor self-starting by using the split phase machine. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Split phase machine making single phase induction motor self-starting. So we know that single phase induction motor is not a self-started motor. We need to make a arrangement to make the self-starting. Let us consider this single phase induction motor having two windings. If it is one winding, we cannot make the machine self-starting. Suppose if it is one winding, what happened? Let us consider this is the current flow, alternating current flowing through the single phase winding. So due to alternating nature of the current, the flux will be produced, that is also alternating in nature. So during positive half cycle of the current, the positive flux will be produced, plus pi. During negative half cycle of the current, negative flux will be produced, alternating. So the flux is produced due to alternating nature of the current, so the flux also alternating. If it is only one winding available, during positive half cycle we will get positive flux, during negative half cycle we will get negative flux. So if you take the average, it becomes 0. The net flux is 0. So there is no flux developed in the motor if it is single phase winding. So the single phase induction motor, it is converted into two phases, and in the two phases the condition is there should be a phase difference of 90 degree. By making these two things, we can make the motor self-starting. That is, we need to make two windings. In that, the current in the two windings should be having phase difference. Now we'll see what is the advantage of phase difference. So the one current is flowing starting from 0. Another current having phase difference approximately 90 degree. It start from 90 degree. It will flow through the next winding. So what is the advantage? So because of two windings with two different currents with a phase difference, we will get the rotating magnetic flux, RMF. Revolving magnetic flux will be produced. How it is produced? So here during this, see that during this period the current is reducing, so flux also reduced. But at the same time, the second current, the current is increasing and flux also increasing. So one current is decreasing, mean another one will increase. So there will be a net flux will be produced because of two windings, two different current with a phase difference. We always get the rotating magnetic flux that can be used to make a motor self-starting. Right. So to make a self-starting, the first one is the motor is converted into two phase winding. In that, current flowing through the two phase should be having 90 degree phase difference. Then only we will get the rotating magnetic flux. Because of phase difference, always there some flux will be created. So in this method, here split phase machine, the phase is splitted into, the single winding is splitted into two windings. Now we'll refer the diagram. So this is the single phase induction motor, rotor is available. This is the stator, stationary part. There are two windings, main winding and the starting winding. So it is now splitted, that's why called a split phase machine. The current flowing through main winding is IM, starting winding is IS. How to make this 90 degree phase difference? So we are making this main winding having low resistance. Similarly, the starting winding having high resistance. Either by connecting the one resistor we can increase the resistor value, or otherwise the coil itself we can have the high resistance copper coil. Right. So the first condition, the winding is splitted now. Single phase induction motor splitted to two windings. To make the 90 degree phase difference, we have main winding have low resistance and starting winding have high resistance. So due to that there will be a phase difference. Now refer this phasor diagram. The voltage is taken as a reference. So this is the total current starting for flowing from the supply. That we have main current IM and the starting current IS. Sum of these two is the main current. See, there is a phase difference between this voltage and current. Pi m is available between the voltage and current. In that, the starting current and main current, there is a phase difference of alpha because of resistance. Having low reactance and high reactance, low resistance and high resistance value, there is a phase difference is available. So because of phase difference between this Is and Im, already we explained with this, we have a rotating revolving magnetic field will be produced. If it is same means the average will be 0. Now it is difference. One current increasing means another current decreasing. So the net revolving magnetic field is always produced, right? So due to the resistance value, there is a lagging. Current is lagging. Reactance also available. This winding having reactance value also. So based on that, there is a lagging available. Pi m is the lagging between current and voltage. Alpha is the phase angle between starting current and main current, right? So these two conditions are now satisfied. The splitted windings are splitted into two windings. In that, current is lagging. Current is phase difference, that is made by high reactance and low resistance value. Now we'll see the description. So in the diagram, the main winding has low resistance but high reactance, whereas starting winding has high resistance and low reactance, so that we are able to get the phase difference. The resistance of the starting winding may be increased by connecting the high resistor in the series. We can connect, or by choosing a high resistance fine copper wire for winding purpose, right? The resistance value increased by connecting the resistor, or we can use the high resistance copper wire, that already we discussed in the diagram. So by referring the diagram, phasor diagram, what is that? Is drawn by the starting winding lags begins applied voltage by small angle, but Im takes from the main winding lags the voltage by very large angle, right? Is is having small angle, but Im having the the main winding lags begin the very large angle. So there is a phase difference of alpha also available between Is and Im. Now we'll see the further detail. So the current in the main winding lags behind the applied voltage very large angle due to the high reactance, right? Im. Current through the starting winding lags behind the applied voltage by small angle due to the low resistance. So from that we are able to conclude that the two current Is and Im have a phase difference of alpha between them, and hence produce revolving flux, and hence a torque is produced, rotor is start rotating. So our aim is to make the single phase winding into two windings, that is we have starting winding and main winding. Phase difference is created by connecting the resistor or high reactance, high resistance. We are making the phase angle of alpha between starting current and main current. So due to that, we will get the revolving magnetic flux. Based on that, torque is produced and the motor is start rotating. When they pick up the speed and reaches about 70 to 80% of full load speed, the starting winding is cut out from the circuit. So that is done by the centrifugal switch. Now we'll refer the diagram again. So this is the centrifugal switch connected in the starting winding. 70 to 80% of the speed is reached automatically because of the centrifugal action. The switch is open, so the starting winding is disconnected. Only the main winding will be available. So the starting winding only for starting purpose. Thereby it is disconnected by using the centrifugal force by the centrifugal switch, right? So here we make the induction motor with the two windings, main winding and starting winding. That is the first condition. Next one, we have to, there is a lagging between the two currents. So that done by high resistance with low reactance value of the starting current, starting winding. Then low resistance and high reactance of the main winding, so that there is a phase difference. Because of phase difference, revolving magnetic field is produced. So the torque is developed and rotor start rotating. Once it reaches 80%, because of the centrifugal action, the switch is open and starting winding is disconnected. Only the main winding will be available. Now we'll see the further detail. The centrifugal switch is connected in series with the starting winding. Its function is to disconnect the starting winding after the rotor reaches 70% of the full load speed. As IM and IR splitted from each other by an angle, the motor is called a split phase motor. So this motor is called split phase because we are having two different, it is splitted into two parts. Now we'll see the torque speed characteristics. So by referring the diagram, x-axis we have speed and torque. So initially when the speed increases, the torque also increases and reaches the maximum value. Thereby it decreases and reaches the steady state value. This is called a starting torque. It is approximately 150%. 150% of the, at the starting we are able to get 150% of starting torque. Now we'll see the description. The starting torque is directly proportional to split angle. So this torque is directly proportional to split angle is nothing but angle between phase difference between starting current and main current. So based on the torque is produced. They have power starting torque of 150 to 125 to 150% of full load torque. Direction of rotation can be reversed by reversing the terminal of either main winding or starting winding. There is a normal procedure. Either main winding or starting winding, by reversing we can reverse the direction. Low starting current and moderate starting torque. The main feature of this is starting current is less and also starting torque also very less. What are the applications? We will see that. Used in the fan, blower, grinder, centrifugal pump, washing machine, oil burner, office equipment, etc. In that we are using this split phase single phase induction motor. So in this video we discuss how to make the single phase induction motor to self starting using the split phase machine. The winding is splitted into two parts and making the current lagging between the two windings by using the resistance and reactance value. Due to that phase difference, the revolving magnetic field is produced and the torque is developed and rotor is start rotating. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.